All right, so basically what we would see, the outline for today's meeting is to understand what PLS SEM is and also when to use SEM, the minimum sample requirement for SEM, then the path modeling and then hypothesis development. And we'll look at the model creation using SmartPLS, then collecting and preparing the data so you can be able to use for the analysis. Then we'll talk about evaluating and interpreting interpretation of the measurement model. Then we also look at the structural model. Yeah. So somebody will ask, what is SEM? This whole business of SEM. So SEM basically is a method of structural equation modeling, which allows you to model, simultaneously estimate and test complex theories or causal relationship, cause and effect relationships with latent variables where you use empirical data. So the objective basically is to maximize the explained variance of the endogenous latent constructs of the dependent variable. So basically that is all SEM is about. So we want to see to analyze complex relationships. There are some relationships that cannot be measured directly. It's so complex. For instance, if you want to measure, say, anxiety level, use of maybe technology on anxiety, it's a complex like cause and effect analysis that you need to employ very robust analysis tools to be able to do that. When do you use SEM? I said that we can use SEM when we want to test a theoretical framework from a prediction perspective. You want to predict a behavior, predict an outcome. You can use SEM. If you want to test or validate a theoretical framework such as TAM, Technology Acceptance Model, you want to look at customer behavior models and all those things. If you want to test those frameworks to see how they are predicted or their predictive relevance and all those things, you can use SEM. You can also use SEM when the structure model is complex, as I said earlier, and includes many constructs or relationships. The relationship is so complex, you can use SEM. When the goal is to better understand increasing complexity by exploring theoretical extension of established theories, as I said earlier. So TAM, for instance, if you take technology acceptance model, it's an already established model. And so if you want to understand the increasing complexity of it, you can employ SEM, PLS SEM to do that. When the path model includes one or more formative measures, you can use SEM. When the research is based on secondary or archival data, which lacks a comprehensive substantiation on the grounds of measurement theories. Yeah, so you can use SEM for that. When the population is small, you can use SEM. Later on in the discussion, we'll look at the required sample size in order for you to conduct SEM. And so when the sample size is small and you want to establish a complex relationship, you use SEM. That being said, you can also use SEM for large, data sets or large sample sizes. So it's not only for small, but it's ideal for small. And when you have issues of distribution, then lack of normality, you can use SEM for that. Finally, when the research requires latent variable scores for follow-up analysis, you can use SEM. Yeah. So what softwares can we use to analyze SEM or PLS? Partial least squared based on structural equation modeling. What softwares can we use that for those analysis? We can use SmartPLS, which is what we'll be learning today. So you can get it at this link. I think that I will not bore you so much with the link. You can access it later. Yeah, so you can get SmartPLS at this link. You can use Amos for it. You can use EQS at this. You can use literal. You can use M plus. You can use R. You can use JASP, and you can use intellectual statistics to analyze your PLS SEM. Now, so earlier on, I was talking about sample size. So basically, this is how it goes. If you want to perform analysis using SEM, there are required samples based on the number of constructs or the number of arrows that are going into a particular latent variable. And so the picture I've shown you right now gives you the various number of constructs and the number of samples that you need. So for instance, if you want to, the minimum sample required with R square value of 0.1, 0.25, 0.5, 0.75 in any of the dependent constructs for a significance level of 1%, 5%, and then 10%, assuming that the commonly used level of significance power is 80%. So when the level of statistical power you're looking at is 80%, this is a table, a rough idea of the number of samples. For instance, the maximum number of independent variables in the measurement model and structure model, if it's 5, for instance, if the number of constructs you have is 5. So backtrack a little. Latent variables basically are the main variables that you are using to assess your model. So then the observed, so there are two. You have latent variable and observed variables. The various observations are the indicators you use to assess those measures. So for instance, if you take technology acceptance, there's a construct we call, say, behavioral intention. Behavioral intention has some indicators under them that you use to assess that behavioral intention. So in that case, behavioral intention is a latent variable, and then the various indicators you use to assess behavioral intention is what we call the indicator variables. So please note. So for instance, if your constructs, your latent variable constructs are 5, and then you want to get an R square value of 0.25. Later on, we'll look at the acceptable or appreciable level of R square values that you need. Then you need a sample size of 70 to be able to achieve that at a statistical power of 80%. Basically, that's what the table is talking about. According to here, he said that in doing SEM analysis, a sample size of 200 is considered to be fair, and then 300 is considered to be good enough. And so you're looking at a minimum threshold of 200 and above. There are some reviewers that will give you like the number of samples that you should use, or give you an idea. If you are in a dilemma, you can use G-Power software to determine the number of sample size you need. Yeah. So that is for the sample size. Now, these are some of the notations. So when you are performing structural equation modeling, these are some of the notations you should look out for. So when you see a circle or an oval, it means that it's a latent variable. And I believe I have explained what latent variables are. Can anybody help us? What is a latent variable? Hello? Okay, good. So a latent variable basically is the construct on which you are collecting the information. Then the observed variable is what you are using to collect the information. Then you have the unidirectional path, you have the disturbance error, you have the measurement errors and correlation. Most of this from here, from this place, measurement error are mostly seen when you are using AMOS and other statistical tools. You can see some of these notations. So please take note of these notations. Now, that being said, that's a brief intro about SEM. So that being said, let's go to why we are here today, SmartPLS. So SmartPLS is a software that is available for you to be able to use to do your analysis when it comes to PLS. The reason most people like SmartPLS, is because of the graphical user interface, which you see later on. It's very easy to use. I mean, you can get free student version, but the student version, you have to restrict the number of observations to 100. You can also subscribe for 30 days professional trial version, which will take you after 30 days, it will expire, you can install. Then you can also buy the full package if you have the resources. Yeah. So you can find the student version over here. So because it's a hands-on training we are doing today, I think that I will allow about 2 minutes. If you have not downloaded the software yet, we'll go through the process of downloading it. That is why I ask that you kindly unmute your mic so you can follow me if you have any question. So I'm going to end my slideshow, then we can begin the process. Is that okay? Hello?
Yes, doctor.
Okay.
Yes, Jiangsu,
Please.
It's okay.
All right, good. Just a moment. All right, so with the all right, so with the link I just spoke about, if you click on the link, I'm going to copy the link and put into the typing area so you can copy and then paste. I know some of us don't like typing, so it's okay. I'll copy it and put in the, how do we get that? Chat. Okay. Please, have you gotten access to it? Can you all see the link? Hello? Hello? Can you hear me?
Yes, we can see
Yeah,
it.
we can hear you.
Yes, so have you accessed the link? Can you all see the link I posted? Is it okay?
Yes, I think it's accessible.
Good,
Yes,
good.
yes, we
So
can see you.
for those who have not downloaded, let me know the number of you who have downloaded and installed. That way we'll not waste too much time with the download process. So who are those who have downloaded and installed? Anybody? Great. Okay. Good, good, good. Excellent. Excellent. So please, if you have downloaded it, type yes. Type yes. Type yes. You can copy it directly into your browser. You can copy it directly into your browser. So I'm gonna pretend to be downloading it for the first time. Okay. So I'm gonna copy from here. You can copy from the message section. Then you go to your browser and then you paste. You paste. Right, right, good, good. Okay, okay, good. So this is the link. So when you come here, you see the various packages you can download here. Download from here. Then after you finish downloading, it will ask you to save at your target location. So you do that. How many people have installed, please? Kalu, have you installed?
Good morning.
In the process
Yeah,
of installing.
yes, I've installed.
Excellent, excellent.
I
Okay.
actually did it before this meeting started. I followed
Excellent.
the tips from the yeah. Thank you very much.
That's fine. That's fine. Ruth Apia, have you installed? Salah, Noah, Philomena, Kezia, have you all installed?
No, please.
Okay, good. All right. You can't find the link?
Yes, please.
Okay. All right. I'm gonna share it again.
On the top.
Can the president put it on our page?
Okay. Thank you. Okay. Yeah, I've shared it again. Good. Thank you. Thank you. Thank you. Somebody has shared it too. Excellent. You guys are useful. All right. Good. So going forward, if you have installed, you should see a button like this. If you have installed, you should see a logo like this. At the down where the tax bar is, your tax bar. Here. You can find it here. Okay, you can find it here. If you are not able to locate it, you can go to your start menu. Your start menu, you find SmartPLS. If you can't find it and you are using Windows 10, you can type at the search button SmartPLS. Once you start typing, it's intelligent, so you'll be able to do whatever. Yeah. So when it comes, you click on Open. When you open, there's the interface it will give you. Please, can you see my interface?
Yes.
Excellent, excellent, good. So this is the interface it's going to give you. For first-time users, you have the option to download the trial version. So you can activate the trial version. Here, you can switch. If you're following my mouse, when you come to information or info, and you click over there, the drop-down option will give you access to switch. So for instance, see, when you click, yeah, so it'll give you the license you have currently and give you the option to change. You can change from here. You can change the license. Yeah. So you can change the license to 30 days. With the 30 days, you have to input an email and then they will send you an email confirmation to activate the 30 days. Good. So I think that Francis asked you guys to install. So I'm under the impression that majority of you have installed. Is that the case?
Yes, we have.
Dr. Lachi.
Yes, please.
Excellent. All right, good. So this is the interface for SEM. There's SmartPLS, sorry. Now you have the file menu where you can create your new project, you can create your new path model, save as options, you can switch your workspace, you can import a project. Import projects basically means that if you have an existing project from another machine, you can bring it into a new SmartPLS without starting the whole coding all over again. So you can just import. You can import from a file, you can import the data, you can import exports and other things. Yeah. You have the edit where you have copy, delete, rename, the latent variables, which I have explained. and other things. Most of them are inactive because we have not started the real analysis yet. Once we start, to begin to be active. Theme. So the theme, you can be able to change some of the outlook of the model and stuff. Then calculate. This is where most of the things you'll be doing will be. You do the calculation, you do the PLS algorithm, you do the bootstrapping, you do the blindfolding, you do the PLS predict. We'll look at all those into details as we proceed. Yeah. So this is the Project Explorer. The Project Explorer is the portion where you can be able to start to create your project. Okay. Now, let's go to this other link. Let me share this other link with you. There. Okay. Yeah. So this. Okay. Excellent. So if you can see my slide, can you see my slide? Quickly, I will just. Please, can you see?
Yes.
Yeah. Good. So today we're going to use a sample data from this website. It's a UTAUT, a Unified Theory of Acceptance and Use of Technology. UTAUT model is for technology adoption. There are other trial projects that you can download from the website. So you can copy that website. Yeah. You can copy that website. Let me see. Okay, I'm going to paste it. Excellent. So copy this link and then go and download copy paste into your browser. You see Unified Theory of Technology Acceptance out. Then you click on the link, download double samples. Have we downloaded it? Are we there? No? Okay, good. So now we want to download, we want to start the process. So we want to download the data we'll be using. So the sample data we'll be using is from the website I just shared. This is the website. If you can't find it, when you go to SmartPLS websites, you can just choose resources. When you go to resources, you see the various resources there. Getting started, recent documentations, videos, choosing PLSM, SmartPLS techniques. You see blindfolding, bootstrapping, confirmatory, and etc. When you scroll down, you see SmartPLS project examples. Yeah. You can all see my browser, right? I'm not sure. Can?
A little bit.
Oh, okay. It's not too visible. Let me increase. Okay. All right. Good. So here, see project example. You have corporate reputation model, European customer satisfaction index, organizational identification project, technology acceptance model. That's the term, the original term. Then you have the unified theory of acceptance of technology. So you click on this link to download. Then when it opens, you click on this other link, downloadable sample project. It's going to download, and if you can follow my mouse, it's here. It's going to download over here for you. So depending on how you have set your download targets, it can be at your download files, can be at your desktop, depending on how you have set it. But for easy recognition, you can just click on this arrow pointing at the top, just at the down here. Please follow the mouse. Don't follow that. Great. So you can see show in folder. When you click show in folder, it will send you to where you downloaded it to, in case you don't know exactly where you installed it or you downloaded it to. Yeah. So you see it's in a zip file. It is in a zip format. So you can right click on it. If you have WinRAR, you can just extract. When you extract, it will come to a folder, and you can see the options. Yeah. For now, just copy the UTAUT-722. The file, the CSV file that looks like Excel. Copy that one to a simple location that you can easily recognize. Okay, so you can just copy and then paste any other location. You can also leave it here if you can be able to. Please, we are doing it together. If you have any question you want me to slow down.
Doctor.
Yes, sir.
And please, what you have downloaded the Excel file, could you share it with me on WeChat, and I'll just share it among all that groups so that it could be.
Okay, let me see. Let me see if my WeChat is still.
Thank you.
All right.
That would be great.
Okay. Let's see. Okay. I have sent it to Francis. You put it on the group. You can just let us share. Yeah. Are we all on the same page, please?
Yes, we are. Thank you.
Okay. Yeah. So, assuming without admitting that all of you have installed, this is the interface you see. Okay. Now, the first thing you do when you see this interface is to create what we call a project. So to create a project, you can get it from here. It's over here, new project. You can get it from here, new project. You click on it. This window will open for you. If you don't want that to, you can come to File and choose Create New Project. It's the same interface. So you can either get it on the quick menu bar here, or you go to File and you choose New Project. All right. So, are we all on this page? No? Caleb, what is the problem? Caleb, what's the problem? Are we going too fast?
A little bit.
Okay, sorry. So, if you have installed the SmartPLS, you should be able to see this interface. That is, if you have installed and then you have registered for the 30 days or the student version.
Yes.
You should be able to see this interface. When you see this interface, the first thing we want to do, so when you see the Project Explorer, there are already existing projects that are there by default. Yeah. So today we are not looking at the existing projects. So we want to create our own project. Okay, good. So someone is giving me a lot of feedback. Okay, excellent. Good. So you can click on new project from here. Okay, here, new project. New project from here. New project. If you can't find it here, then it means that you have not activated your SmartPLS. Or if it's not there, you go to File. When you go to File, choose Create New Project. New project. So it gives you the same interface.
Doc.
Gloria, are you? Yes.
Yes, Doc.
Okay.
Sorry to interrupt. Please.
It's okay.
I only have ECSI PLC SEM book, then archive on my own.
That's fine. Okay, that's fine. Ignore the other things you see here. Okay. Let me delete those. Yes. So you should see something like this at the first instance.
Yes, please.
Excellent. Good. So you see new project. Click on new project.
Okay.
Yeah. If you can find it over here, you can go to File. You go to File.
Okay. So a dialog box pops up.
Excellent. So we are currently at the dialog box. Please, let's follow each other.
Okay.
Let's follow so we can go like systematically.
Okay.
Yeah. So I presume we are all at this place. Ignore my circle. Yeah. Okay. We are all here, are we? We are all here. So
Yes.
at this interface, what you do is that you name your project. Excellent. Thank you. Good. So we name the project. Okay. For easy identification, we'll all name it UTAUT. 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 You can actually name it whatever you want. Yeah, but for easy. So I'm naming it UTAUT, and then all I need to do is to click on OK. Good. So when you click on OK, you see the gentleman who asked the earlier question. You see that a new project has been created. So the new project you have created will now follow directly the PLS book corporate reputation model, but it will have a red exclamation sign on it, or caution. Then just beneath it, you see the information symbol. Then you also see the path model, that has been created for you. The path model takes exactly the name of the project. How you name the project is the same way the path model will come. We'll come to path model later or in the process. Yeah. So if you don't like the name, you can rename it. You can rename it to, who should I name it after? Collins. Yeah, We can name it Collins. You can do whatever it is you want, but I'll not. Please, are we all at this point? Yes, yeah, I can see 2 yeses. Good, good, good. Great. All right, so now what we're going to do is to import our data. We are going to, good, 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 good. Excellent. So we are going to import the data. All you have to do is double click on the information just beside the information icon. When you double click, then it would open an interface for you where you can select the data. Now, SmartPLS does not select any other file format apart from CSV. So if your data was saved in, say, .sav, that is, if you saved from SPSS, then you have to convert it to CSV, .csv. CSV is comma delimited .csv. So let me digress a little bit. So say the data you collected or the data you have is in a complete Excel format. It's in the format *xls or it's in *xlx or it's in any other format. If you are saving from Stata, it's going to be .dta. I mean, if it's in any format, for instance, let's say my data is in Excel. I've saved it in the original form of Excel. What I need to do is I come to Save As in Excel. That is assuming you are taking the data from Excel. Then I go to my target location. Say I want to save it on desktop. The window will come. When the window comes, you see Save As type. This is just a digression. I'm just showing you how to convert to the appropriate format. So you can save it as type. Save as type. So when you come down, you see CS, you see micro enabled and the friends, the twin brothers and the sisters and all those things. Then you see CSV, comma delimited. That's the right format SmartPLS takes. So choose that format and then you save. Once you save, it will ask you whether you want to change the format of it. You say yes, and then you are able to save it appropriately. Good. So SmartPLS only takes the file format of CSV. When you start playing around it, you can be able to import a text file, .txt. But that's at a later time. We'll talk about that later. Yeah. So I'm gonna double click here, and I'm gonna select my .csv file because the data we had downloaded is already in CSV. It should pop up for you. Then you select it and you choose open. Great. So when you choose open, you see import data file. A pop-up window will show. Then the name will come, and then you can either rename it or not. Then click on OK. Great. So when you click on OK, you should be able to see a data like this. So you see the type, you see comma delimited for that. You see the sample size you're using. You see the indicators, the number of indicators that were used. We spoke about indicators earlier. Yeah, they are used to assess the latent variable. Then you see the missing values. So because this data was worked on before, it has been cleaned. So there's no missing value. Yeah. So when you check under, I can't see the data. June, what is the problem? Okay, June, I'm gonna take that portion again if you can see it.
No, hey, excuse me.
Okay, good. So June, so the
Yes.
new project we have created, you should be able to see a red exclamation mark or the information. Yes. Now,
I've done all that, but when I click it to open, it says the file contains too many observations. You must upgrade to a professional license if you want to use it. How do I upgrade?
did you download the file he sent?
Yes, I did download.
And where did you save it at?
I saved it on my desktop as a CSV file.
Okay. And when you click on it, it tells you.
I cannot see the data, so I have to upgrade to a professional license if I want to use it.
Oh, good. So you are experiencing the problem I earlier on spoke about. So as I said earlier, if you are using the student version, you can only be able to perform analysis on 100 observation. The data we have currently is more than 100 observations, so you can't use it. So to activate the professional version, as I said earlier, I don't know what time you joined, but you can be able to activate the trial version for 30 days.
Okay,
So,
thank you.
Great. Let me see. Good. So when you download from here, you can how do we call it? Go to where's the website? Good. Purchase. So purchase. You see 30 days. Start free 30 days trial. June. So you can click on free trial. It will ask you to input your email to be able to use. Yeah. So you input it. They will send you a code and the necessary instruction for you to activate the professional version, for which you can use for 30 days and access all the functionalities.
Okay, thank you, sir.
You're welcome. Any other person experiencing the same thing? So can you please type yes if you have been able to install the professional version? Yeah. If you've been able to install the professional version, please type yes, so I know we are all on the same page. Else, then I would have to go on without you following at every point in time. Excellent. O'Brien, good.
Sir,
good.
I'm sorry for interruption.
That's okay.
How can we now use the professional version?
Okay, good. So for those who have downloaded the student version, you can be able to change the license. Okay. You come here, you come to information, the information menu, you switch license. When you open that, because I'm not on student version now, but you can see change license. When you click change license, you can see professional version. Okay, then they'll ask you to input the key Because you don't have the key, you can't be able to install it. So what you have to do is to request for a 30-day full-featured trial. So you click on it, it will send you back to this page. I shared the link right now. So to avoid all those process, you can just input your email over here. Once you input your email and submit, you should get an email notification that they have sent you either the key or the procedure you should use to activate your professional version.
Okay, sir, got it. Thank you.
You're welcome. Any other concerns? Okay, great. So now that we are on the same page, good. So now for those who have installed the professional version, I think that I'm going to go quick. Let's see. You should be able to see all these things I have displayed. So under the utility, the path model, you should be able to see the data that you have been able to import. It should show a green sign and the number of records you're using. So the number of records is the same as the sample size you're using. It should also indicate for you the number of indicators you'll be using, as I explained earlier, then the missing value. So just beneath that, at the indicator menu, you should be able to see the various indicators, the number as it has numbered it up to 21. You should be able to see some of the descriptives. You should be able to see the mean, the median, mean, max, standard deviation, the kurtosis. If you want to see the distribution of the data, you use the kurtosis and the skewness. You can use and the standard deviation. You can use those to see how the data was distributed and stuff. Yeah. Good. If you go to the indicator correlations, you see how the data correlates with each other. Okay, so you see how the correlation moves for each of the indicators. And when you go to the raw file menu, you should be able to see how the format of the data is. So the raw file menu basically gives you an idea of how the CSV file is looking. So normally when you save CSV, because it's comma, if you saw the delimited or the option, that's how it appears. Normally when you save using comma delimited. Great. So that is how to import your data. That's how you import your data. You can also import from the file menu. Okay, you go to file, then you choose import data file. It gives you the same option. Import, because we have a duplicate to tell us 6. Good. So you can import as many data as you want, as many as you want. Any question? Can I proceed? Yeah, can I proceed? All right, so proceeding without your permission. So the model we got, no questions for now. Okay, good, thank you, great. So now we're gonna look at the various, so you should see that. Good, import the data. Great. So now, how are we going to perform our analysis? Now we want to zoom, so we have our data now, we want to do the analysis. One thing you should avert your mind to is the various hypotheses you're going to use. Mind you, we want to use the UTAUT model. As I said, UTAUT is used to assess technology acceptance and adoption. And so if you are looking at that, then you use there are already established models for that. That is the UTAUT, the TPB, the TAM2, UTAUT2, and all those things. So this typically how the UTAUT model looks like. You have 1, 2, 3, 4, 5, 6 latent variables, and there are various indicators. So you want to see whether PA is what we call performance expectancy. So the constructs are performance expectancy, effort expectancy. So performance, I don't know if I should explain. Okay, so since we are using it, performance expectancy basically is how useful the system the technology system is, the ease, how useful it is, usefulness. Then effort expectancy explains how easy it is to use. Then social influence or social networks is how your surrounding, your social networks, your family, your friends, those who have influence on your decision, how they influence your use of that system or that technology. Then facilitating condition talks basically about the various enabling environments for you to be able to use that technology. For instance, access to internet, access to a computer, and access to electricity, all those things. Okay. Then behavioral intention talks about the behavior, the person's behavior to want to use it. Then actual use basically measures the actual use of the technology. Yeah. So that is a brief explanation for it out. Yeah. So this is the model we want to create. Now, so from the model, depending on what you want to do, if you want to do a customer reputation model, there's a model that you follow. Now, we want to be able to deduce from this model the various hypotheses that we'll be using. So next, I'm talking about the hypothesis development. Now, we have seen this, what this means, the arrows and all those things. So we want to see the impact of performance expectancy on behavioral intention. That is one hypothesis. We want to see performance expectancy, the impact it has on the behavior of people. Okay, the usefulness of, say, a system. Does it affect the behavior of the people to use that system? Number two hypothesis we're going to look at is the ease of the system or the ease of use of the system. Does it influence the behavior to use that system? Then hypothesis three, we are going to look at whether or not somebody's social network influences their behavior to use a certain system. Then number four, we're going to look at whether or not the various facilitating conditions promote the use of a system. Okay, good. Normally, when you take the typical UTAUT model, you see that facilitating condition also goes into behavioral intention. Finally, we want to see whether somebody's behavior really influences their actual use of a system. So those are the various hypotheses we'll be looking at, just to see how SmartPLS works. Good. So this is my hypothesis. So PE has positive impact. So normally when you're writing your paper, this is how your hypothesis development is. The structure is that you come up with the theories, then you come up with a conceptual framework. So if you were writing a paper this would have been your conceptual framework, a paper or a thesis. Then there's the hypothesis. Okay, the various measures we want to test. So we want to see whether PE has positive impact on BI and so forth and so on. Okay, great. So that being said, and having this picture at the back of your mind, we are going to draw the path diagram. Okay. Please, am I going too fast? Okay. So you double click on this, the blue icon with some yellow 2 legs. You double click on it and it will open nicely for you, a whitish window. Okay, great. Now, once it opens for you, this interface is what we call the path interface. Okay, the path interface. So you come back here, you choose latent variable. So latent variable, you click on it and you drop it on the interface. So you see latent variable 1. So it's still on it, so you can just duplicate. You can just as many as you want. Okay. You can just do that. Now, when the mouse pointer turns this way, I don't know if you can see, when it turns this way, any click you do, any right click you do would insert a latent variable. So if you want to reposition this latent variables, what you do is that you come to select, then you can move them. So can you remind me, how many latent variables does the UTAUT model have? The model we are using. How many latent variables? You can just type, how many latent variables? How many latent variables? 6. Excellent. Good. All right. So it has 6. So now we have a total of 8. So we can just click on the ones we don't want and just delete. Click and delete. Okay. Click and delete. You can, play with it as you want. How you want the diagram to look. You can just, it doesn't matter. Okay. So if you insert a latent variable, the original color that appears is red in SmartPLS. Okay, it's red. Now, since we know the names of the latent variables we want to use, P, E, E, S, N, we can rename the latent variables now. So the original names it gives you is latent variable 1, and then it does it serially. So you can just right click on it, on the particular one, and then you click rename. It will give you an option to rename it. Okay, so PE is performance. Okay, then you can do same for the rest of them. You right click and then you choose rename and effort expectancy. Efforts. Then I'm gonna name this social. Says, are we able to record? I think there are some people. It's recording, right? Okay, excellent. Then the last one, I'm going to rename. So please, if you are able to rename, just go ahead and rename it. Okay. Facilitating condition. Facilitating 6, I'm going to name it behavior. Then 7, I'm going to name it actual use or use. Okay. Yeah. So for me, this is how I want the model to look like. You can determine how you want it to look like. Put this here, you can put that here, whatever suits your eye. I think the statement beauty lies in the eyes of the beholder should work. Yeah. So you can click on the various junctions and then expand it, the latent variable, as you want. You can also come to the theme, more theme, and change the color you want to use to change the latent variables. But we'll come to that later. Yeah. So the various Windows shortcuts also works. The Control Z, undo, and all those things, they all work. Interface. That's what I mean. Very nice things. So now we're going to connect our latent variables. Okay, latent variables. The reason we are connecting them is that from the hypothesis, we are saying, for instance, the first hypothesis, we are saying performance expectancy has a positive impact on behavioral intention. And so first we are going to create that link. So you come to connect. The connect icon is here. Please, am I going too fast? Okay, good. So you come to connect, you click on connect, you point to the first one here, performance, you drag down to behavior, and it's established a link for you. Then from effort to then from social to this one. Please talk to me. Are you with me? You're following? I'm unable to delete. Yeah, so if you're unable to delete, choose the select and then click on the latent variable. It will change to, I mean, with the surrounding and the junction, and then you can just click on delete. So it has to, yeah, that way. So the person who just asked about deletion, you go to select, click on the variable, and then just delete. Okay. So select helps you to move the various components around. Okay. Are we able to create the links? Establish the links. Okay. Excellent. Thank you, Brian. So I don't know if I should do it systematically, but so we have first of all established our first link, that PE or performance expectancy has a positive impact on behavioral intention. The next one is effort expectancy has a positive impact on behavioral intention. So we create the link between them. Come to connect, click on effort expectancy, and connect it to behavioral intention. The third hypothesis is facilitating condition has a positive impact on behavioral intention. So we come back here, facilitating condition to effort expectancy. The fifth hypothesis, fourth I think, is social network has positive impact on behavioral intention. Caleb, you're getting error. What is the error saying? What's your error saying?
They are not connected.
They are not connected. Yes. So you click on connect, the connect, or you can use Alt +3. When you click on, are you following my mouse?
Yes. Okay.
Here.
The quadratic is connect.
No, don't use quadratic. Yeah. So Caleb, when you click on connect, do you have what I have currently? Caleb, do you have what I have currently?
No.
No?
No, please.
Okay, great. Any other person facing the same problem he has? Okay, great. So I'm gonna assume it's only Caleb who has the same the problem. So Caleb, so what you have to do is first you click on select, then you select the latent variables. You select and click, right click to, insert them on the path window. Have you done that, please? Sorry?
Come again, please. I didn't get that, please.
Can you say that again?
Can you come again, please? Can you go over again? What did you say?
Okay. You don't get it.
Hello?
Okay. Okay. So for Caleb's sake, Caleb, so what you have to do is that from here, from this window, please be following my mouse. From this window, you double click. It opens the path window for you. At the path window, we are going to drop the number of latent variables we need. And per the model we saw earlier, this model, we need 1, 2, 3, 4, 5, 6 latent variables. Please, do you get that? Caleb, do you get that?
I'm looking at your mouse. Okay.
I can hardly hear you.
Yeah. Can you hear me now?
Yes. So are you currently at where I am?
Yeah.
But I couldn't follow.
Can you get me now?
Okay. So some people are saying they can't follow. So anybody else getting error apart from those two people who cannot follow? Otsuri cannot follow. Maxwell is getting error. But I mean, it's just a click and drag and position. I mean, so when you come to select, you click on the latent variable, you drop it. So we need 6. So you drop it to 6. I think because of the time, if you are following, same here. Okay. So what is the problem actually? Okay. Isabel. All right, so I'm gonna do a quick roll call. If you are following, let me know so I know the number of people who are able to. Philo, are you able to follow?
Yes, Dr.
PG leader, are you able to follow?
Yes, please, I'm able to follow.
Right, 203, are you able to follow? I think index number ending 203. June, are you able to follow? Mochiwedi, I don't know if I got it right.
Sweaty.
Okay, thank you. Are you following, please? Onela. Ifan, you're following. Gloria, are we all on the same page?
Okay.
Leslie Odai, Marina. Yes.
Yeah, I think if we are going to follow who is following and who is not following, it appears we may not go anywhere because it looks like so much. So what I suggest is that because you cannot use a single day to be able to grasp all this.
Okay.
In the course of time, as maybe if you are conversant with the tools, then you begin to ask more questions.
Okay.
But so I bet that we proceed.
Excellent.
So that subsequent time, if you can ask further questions, it will be clarified. Other than that, we won't go anywhere. Thank you, sir.
Excellent. Okay, good. Thank you.
So, also, we are recording the screen, so probably we can share and then people can follow at their free time.
Excellent. So those who are following, that's good. Excellent. So we're going to establish the connection based on the hypothesis we have posited. All right. So we're going to connect now to this one, this to that, this to this. Okay. Then we connect back this to that. All right. Then I'm going to delete this link because it doesn't appear in our model. So how to connect? Click on the connect from the one latent variable to the other one. Okay. Now, if you want to rename a latent variable, just right click on the latent variable and then you see the rename option. If you want to delete, right click on the latent variable and then you see delete option. Okay. So you click on that and then you type the name, your preferred name you want. So I'm currently doing that. SN. FC, facilitating condition. BI, behavioral intention. Then use. Okay. Good. So this is how the interface looks like. Now, so you see from here to here, from PE to BI, E to BI, Sn to Bi, Fc to use, and then Bi to use. Okay. Now, to proceed, so initially, if you have not added any indicator to the latent variable, it's red. But once you choose the indicator and put on the latent variable, it should change. So how do we now input or attach our observed variables or indicators to the latent variables? So when you come down, you see the indicator menu or window. Then you see PE1, PE2, PE3, PE4. Okay, it means that these indicators measure the PE. Okay, so we click on it. You can click and then press the control key on your keyboard to hold. Then select the 4. After selecting the 4, you drag and put on the latent variable. It should change color for you to blue. So the latent variable changes to blue, and then the indicators or the observed variables change to yellow. Now, so I'm going to do similar for all the other constructs, and I expect that you're also doing those respectively. Good. Good. Facilitating condition should change. As I said earlier, you can decide to, position the latent variables anyhow you want. Okay. Great. All right. So because this doesn't look nice for me, I can just right click on it and then I choose align indicator to either top, left, bottom, or right. Okay, so that way. You right click on the indicator or on the latent variable, and then you choose top, left, bottom, right. You can do same for all of them. Okay. You can also pick. You can click on them and then spread them along. You can do all that. Okay. So now, this is what we call the path model. So this we have drawn right now, or what you can see right now is what we call the path model. Okay. And you draw your path model based on the hypothesis you have developed or you have posited. And you posit your hypothesis based on literature. So that is how it goes. Okay, based on literature, you construct your conceptual framework or your research model. Then based on the conceptual framework, you are able to posit your hypothesis. That order. Okay. Great. So now, what do we do next after you have done that? Then you do what we call model estimation. You estimate the model. So for PLS, PLS-SEM, the model estimation is in two folds. Okay, you estimate the model to produce what we call the empirical measures. Okay, so you're looking at the relationship, how strong the relationship is, what indicators contribute most to the model, what is the predictive relevance of the model, what is the contribution of the various indicators to the latent variables, and so on and so forth. So the model estimation in PLS-SEM, first of all, you assess what we call the measurement model. You assess the measurement model, then you also assess what we call the structural model. Okay, good. So the measurement model, what you are going to be looking out for is the reliability. You also test for the convergence validity and then the discriminant validity. That is the measurement model. The structural model, you're going to look at the R square, that's the explained variance. You're also going to look at the effect size. You're also going to look at the predictive relevance. Okay, so you look at R square, F square. These are the measures you use to assess your model, okay, or to estimate your model. Yeah. So there are two types of processes. So you realize that we are doing all the analysis systematically. So SmartPLS or structural equation modeling is in a systematic order. So first you create your model, then you import your data, then you do your analysis. You do your analysis depending on what kind of, model it is, whether it's reflective or it's formative. I think you can read later on reflective and then formative models. Then you do what we call the measurement assessment, the measurement model assessment, and then you do what we call the structural model assessment. So when you're doing the measurement model, you're looking at the internal consistency reliability, where you look at the Cronbach alpha and the composite reliability. The convergence validity, you look at the indicator reliability, that is the loadings. Then you look at the average of variance extracted, the AV. And then the discriminant validity, you look at, you assess it using the Cornell and Lacal criteria, use the cross loadings, the HCMT. Okay, so now, so how do we then run the analysis? Okay, now when you come down, you see calculate. When you open your SmartPLS, you see calculate. That is, if you have drawn the model very well, you see calculate. So you click on calculate, then you choose PLS algorithm. You click on it, a beautiful interface comes for you. What we are doing is a path analysis. So in PLS, you can also do factor analysis. Okay, complementary factor analysis. You can click here to read more if you want to know more about what PLS algorithm is. Now, so the maximum iteration, you leave it at 300. You can increase it, you can decrease it. The narration as to what maximum iteration is. Maximum iteration basically is the number of calculation or calculation steps that the model is going to perform to be able to arrive at the results. Yeah. Then the stop criteria is all there. You can read it. So now we're going to leave it at the default, and then you click on start calculation. Yeah. So it's going to do all the calculation for you and present the results for you. So the current result we can see here is what we call the path coefficient. We'll look at that as we proceed. So to be able to view these results properly, you can export to Excel. So you click on export to Excel and export to Word or R. Okay. So export to Excel and you click on start export. It will save for you. It takes a while to export. Good. So whilst it's exporting, let's look at what we are going to look at. So under the PLS algorithm, these are what you should look for. Number one, we're going to look for the Cronbach alpha. Number two, we are going to look for the composite reliability. And the Cronbach alpha, the thumb rule or the rule is that the value of Cronbach alpha has to be 0.5 and above for it to be accepted. Okay, so according to Nonelli, says 0.7 sorry, is regarded acceptable, 0.8 and 0.9 are appreciable. Okay, so these are the indicators we are going to look. So always make sure your Cronbach alpha value in assessing the measurement model is 0.7 and above. Now, so this good, excellent. So our report has been exported to Excel for us. So the first thing we are going to look for is the construct reliability and validity. This under quality criteria. So we are going to first assess the quality criteria. Okay, so you click on show. When you click on show, it should open the various results of the calculation for you. All right, the first one we are looking for is the construct reliability and validity. Okay, now, so you see from here the various latent variables. There are Cronbach alpha values, their rho, their composite reliability, and then their AVEs. Okay, good. So from the construct reliability, we said that alpha values have to be 0.7 and above. Okay, so from this result, you see that Cronbach alpha for behavioral intention is less than the threshold. Okay, and then FC is also less than the threshold. Yeah, so you look for this, and then you look for this. So these are the two things you are looking for over here first. Okay, now for composite reliability, the rule is that it also has to be similar to the Cronbach alpha. It also has to be above 0.7 for it to be able to meet the rule for composite reliability. Okay, let me show you. Yeah. So the threshold interpretation is the same as the alpha value, as I said, stated. Good. So now what we are going to do is, this is the result of the internal consistency. This is the table you use to display the results. Okay. So now what I'm going to do is that I'm going to copy, for instance, performance expectancy. I'm going to copy it from here and put over here. Good. So you see 0.85 is above 0.7, right? So we'll say that the Cronbach alpha is reliable. You do same for the rest of them. Because of our time, I'll not do all of them. Okay. So in your narration, you say Cronbach alpha for all the latent variables met the threshold according to Nonelli's criteria, except the BI and then FC. That is the APA format of reporting these values. Okay, good. I'll share the.
I'll share.
Yes, yes, yes.
So in that case, if a construct fails to meet the threshold, as we can see for, so what?
I'm losing you. Okay, so ideally, this is how it is. Not all your constructs will meet the threshold. Okay. I don't know if you have finished answering your question. I'm losing you. Okay. Not all of your not all of your constructs will meet the threshold. That is why you report both. I mean, either way. Okay. Now, what you can also do is that normally when the values are low, for instance, for Cronbach alpha, composite reliability, AVE, the loadings, if they are low, what you do, for instance, is that, let me show you something. You see, loadings, we'll come to loadings. All loadings need to be above 0.7. Though some literature suggests that 0.5, 0.6 could be accepted if they cumulatively lead to a higher AVE of 0.5. Okay, but if the indicator you are using to measure the internal consistency reliability of the cross loadings, the outer loadings is low. For instance, if this value over here, this is the indicators, the cross loadings. If it was low, we would have deleted one of them. You can delete. You delete one and then rerun the analysis again and get an improved result. Okay, so that is the trick you do if you want to get all of them to be to meet the threshold. You can delete some of the indicators and then rerun the analysis again. As you rerun, it might improve. Okay, it might improve. The reason it's going to improve is that for this model, you see, it's a reflective model. And so the latent variable is what influences the performance of the indicator. If it was informative, or if it was formative model or measure, then the indicator rather would have influenced the behavior of the latent variable. I don't know if you are following that. There are two differences. There's reflective and then there's formative. Reflective is that the arrow to the indicator moves from the latent variable. But for formative, it moves into it. So meaning that if it was formative, if you delete one, it will affect the performance of the latent variable. But this one, if you delete one, it rather improves the performance of the latent variable because it is going out of it. It doesn't necessarily affect its input. I don't know if you have followed that. You can read more about formative and then reflective. Okay, great. So if the threshold is not significant enough for you, you can delete and rerun and see whether you find some improvements. Okay, great. That being said, we go to composite reliability. So now we are reporting on the measurement models. Composite reliability, you see that all of them are above 0.7. Hence, it has met the threshold for composite reliability. So we put the actual value, we put the actual value here, and then this is the criteria, and then determine whether it's reliable or it's not reliable. Okay, good. The next thing we're going to look at is the convergent validity. Okay, so the convergent validity basically measures the extent to which a measure correlates positively with the alternative or the alternative measures of the same construct. Okay, so in order to assess the convergent validity, you look at the factor loadings, then the composite reliability, which I talked about. So we have seen that already. You also use what we call the AVE to assess the convergent validity. Okay, now, so loadings of 0.7 and above are considered to be acceptable, and for AVE 0.4, 0.50, so for loadings, for instance, as I said earlier on, it has to be above 0.7. But if you get loadings, these are the loadings, these ones, these values, it's ideally supposed to be above 0.7. Okay, now if you find any of the loadings that is lower than 0.7, sorry, like this one, This is 0.69, BI2. Then you go back to the model and see, okay, the AVE value for BI, is it above 0.5? The acceptable threshold for AVE is 0.5 and above. Okay, so you go and see, okay, now looking at BI2, the factor loading is 0.69. Now this 0.69, should I accept it or I should not? And deciding on whether to accept it or not, the rule is that if though there exists a lower loading for the factor variables, the factor loadings, if it is low, but you have a higher AVE for the construct, the latent variable construct, then you accept it. So for instance, if you see this, the AVE for BI is 0.517. And because it's 0.157, we can then accept the 0.69 factor loading, though it's lower than the threshold. Please, do you follow? So I've said same. Loadings of 0.4, 0.5, 0.6, and 0.7 can be accepted if it leads to an AVE that is larger than 0.5. Okay, excellent. All right, so good, excellent. All right, so the next thing we're going to report on is the loadings. So you come to the navigation on the report, the PLS algorithm report. You come to the navigation and then you choose the outer loadings. And the final results, you see outer loadings. You click on it. When you click on it, you see outer loadings. Yeah. So the acceptable rule for outer loading is that it has to be above 0.7, as I said earlier. So when you take all the indicators under BI, all of them are above 0.7 except BI2. But we will accept BI2 because it's cumulatively adds to a higher AV. Next, if you see effort expectancy, you have 4 indicators that were used to assess it. Now let's see their performance in terms of factor loadings. All of them are above 0.7, and so that is good for us. When you take facilitating condition, all of them are above 0.7, so it's good for us. So you can do same, you can check all of them based on this table. Okay, so BI, all of them. And the criteria should be 0.7 and above. Then you remark whether it has fulfilled it or not. Then the AVE, we saw the AVE. You get the AVE from the construct reliability and validity. You click on show, you scroll down, you see AVE. Copy the value, and then you can put it on the table. Then you do the assessment. Okay. Okay. You do the assessment basically. So if you take behavioral intention, I'm going to restrict myself to just one. Okay, so we can all follow. When you go to behavioral intention, it's 0.5. This is supposed to be merged. So you don't need to write for all of them. You can just merge it and then write for just one. Since the AV is measuring the latent variable, not the indicators. Okay, the only thing that measures the indicator is the outer loadings or the factor loadings. Okay, good. So since the AV for behavioral intention is above 0.7, then 0.5, sorry, then we will say that the convergent validity has been met based on this. So fulfilled. So if it's fulfilled, you state it. If it's not, then you state it. Yeah. So that's for convergent validity, right? So as a quick recap, we looked at the internal consistency reliability, where you assess the Cronbach alpha and then the composite reliability, then convergent validity, where you assess the outer loadings and the AV. Outer loadings can be found when you go to the navigation of the report. You see outer loadings under final results, you click on it, and then you see it over there. And then you do the comparison according to the criteria, the threshold. Then when you come to quality criteria under construct reliability and validity, you'd find the AV values or the composite reliability, sorry, values over there. Excellent. Okay, it's AV, sorry. So the next measure we're going to look at is the discriminant validity. Okay, so the discriminant validity is the extent to which a construct is truly different or distinct from other constructs. Okay, so basically you are just testing for the uniqueness of that construct. Okay, so you evaluate the discriminant validity using the cross-loading, the funnel and Lacan criteria, and the HTMT. All right. Okay. So the funnel and Lacan, it says that the AV of the latent variable should be higher than the squared correlation between the latent variables and all other latent variables. So when you come to the navigation, you see discriminants under quality criteria, you see discriminant validity here. Okay, so you can click on it and then you see funnel and Lacan. It's already here. It's already here. You can either copy this. Okay. So good. So funnel and Lacan says that when you square the AVEs, so I'm going to use a mathematical equation here. When you square the AVEs, it has to be greater than the adjacent or the adjacent, if that is how you prepare it, of the other loading. So when you see 0.719, it's the same value over here. Yeah. Good. The red, the one I just, so this value is the same. This is the square root of the AVE. It's the same as this value over here in the Lacan funnel and Lacan criteria table. So the rule for assessing discriminant validity based on funnel and Lacan is that when you take the square root of the AV, which is this value, it should be greater than its adjacent loadings. Okay, so when you take this 0.7, it should be greater than the adjacent ones. Now, the next one is 0.836. When you take this value, it should also be greater than this value and these values, these other values. Okay, now, next one, if you take 0.72, which is here, this value, it should be greater than this value and greater than this value. Same for 0.835, should be greater than this, that, and greater than all other adjacent ones. Okay, good. So in representing that, this is the table. This is the table you use. So you compare the square root of the AVs with the latent variables correlations. Okay, see whether they are greater. So you put the square root over here. If you don't want to do the mathematical calculation, you can just copy this table, this whole table for nil and lacquer. You can just copy this whole table and put them, and just highlight this, highlight the ones here, these ones. Okay. Francis, my time is up, right? Okay. I'm gonna put this.
No problem. We can continue when you're done. I guess we'll be ending soon.
Yeah. I think I will end at some point so we can just go. Maybe we'll continue another time.
Okay.
Yeah. So if you don't want to do the calculation as I've shown in the PPT, you can just copy the table from the report directly, and then you just need to show the square roots. So you can click here and just bold in it. Okay, you can just bold in this ones, bold in it to show that they are greater than their adjacent correlations. Okay, so in that order. If you do it nicely, you see that it follows a slope downwards. Should follow a slope downwards. Okay, I can't see the rest of the table, but it should follow in that order. So that is for Funnel and Lacquer. The next measure is the cross loadings, and you find the cross loadings just beneath the Funnel and Lacquer. You see cross loadings over here. So that is the good thing about SmartPLS. All the measures, you just need to know what measures you're looking for and the threshold criteria. That is all. They all follow. It's all there. Just copy, paste. You do an analysis of them and then just report on them. Great. So this is how this table looks, the cross loadings. Good. So this is the table for the cross loadings. Okay. Now, so for assessing cross loadings, all indicators of the outer loadings on the associated construct must be greater than all of its loadings on the other construct to fulfill the criteria for assessing cross loadings. Okay, good. So in a similar fashion as the Funnel and Lacquer, when you take, for instance, the indicators for BI, you have 1, 2, 3. Let me highlight those. When you take this bolded values, they should be greater than their associated correlations. So when you take 0.736 is greater than that, its correlation with BI1's correlation with EE1, that. Okay. Now, when you take effort expectancy, so you take it from here, it's 4. It should also be greater than these other ones and greater than these other ones. It should be greater than this and greater than this. Okay. So at the adjacent or the opposite sides of them, it should be greater. Okay. Now, when you go to FC, so you get FC from here. Get FC from here. It's 3 indicators that were used. So it's also greater than its adjacent loadings. When you take performance expectancy, 4 indicators, they are also greater than the adjacent loadings. When you take social networks, they are all greater than the adjacent loadings. And then if you take use, it's all greater than the adjacent loadings. And so if you do it well, you should see that it follows a diagonal path. If you bolden it well, you should see it follows a diagonal path from here to here to here, this way, that way, as well. Okay, good. That's how you assess cross loadings. Okay. So, any question? No, I don't think so. Now, HTMT. HTMT is a new criteria that is used to assess discriminant validity. And the rule for HTMT is that it has to be lower than 0.9. It has to be different essentially from 1. Okay, so you can get the HTMT value from discriminant validity. All right, so after cross-loading, you see discriminant validity follows in that order. And when you copy the table, you see that all of them, and the good thing about SmartPLS is that all the results that have met the threshold are highlighted green, and all the results that are outside the threshold are highlighted red. And so straightforward, just looking at it, you should know whether it has met the criteria or it has not met. If you remember, a gentleman asked a question relating to the BI in terms of the Cronbach alpha value. Just looking at it, you see that it's highlighted red. Now, the good thing also with SmartPLS is that you can see the pictorial representation of the assessment models, what you are using to assess. For instance, when you go to, say, construct validity, and then we want to see the Cronbach alpha values. When you come to this menu, this tab at the report, complete chart, you see just beneath, okay, so you see R squared, for instance. See R squared. You see all the greens, okay? If you see F squared, it's there. We will talk about it later. When you see the Cronbach alpha, a pictorial representation is given you. So straightforward from looking at the diagram, you will be able to know whether or not they have met the requirement. So you see BI and FC are lower than the threshold value of 0.7. And so they are in red. Okay, good. So let's go quickly back to the HTMT, which is used to assess the discriminant validity. When you click on that, HTMT. So this AV, all of them have met. HTMT, when you see all of them have to be different from 1, meaning that they have to be less than 0.9 to be able to meet the criteria for assessing the heterotrait monotrait ratio, the HTMT. Yeah. So you see that all of them are green, and from the table to all of them are green, and so it has met the criteria. So HTMT, that is it. So this a summary for your measurement model. Okay, so there are 2 things you look out for when you're assessing structural equation model. You assess the measurement model, and then you assess the structural model. Okay, good. So this basically is a summary. So the summary, you're going to look at the various outer loadings, the AV values, then the HCMT, whether they have met or not, then the Cronbach reliability, and then the composite reliability. Cronbach alpha, sorry. Now, so quickly before we go, let me talk briefly on the structural model. All right. So the structural model basically helps you to predict the performance of the other latent variables on the targets or the main variables you're looking at. In our case, we are looking at actual use area. All right. So, and you can use the structural model to test how strong a relationship is between the various latent variables. You can also be able to use the structural model to determine whether or not the model has a predictive relevance or not. You can also use it to test the hypothesis. Mind you, or remember, earlier on we posited about 5 hypotheses. And so based on these various criteria, the collinearity assessment, the path coefficients analysis, the R-square value, F-square value, blindfolding, and predictive relevance and effect size. You can be able to know whether or not your hypotheses have been accepted or rejected. All right, do we follow? I think that we'll end here on the measurement model. The next time we'll meet, if God permit, we'll look at the structural model, and then we can look at mediation and moderation. All right. Okay. So, Francis, I would like to end here. I think that the installation process took a lot of our time, so we couldn't go so far.
All right.
Essentially.
We thank you so much, Doctor, for your insightful presentation, your willingness, and your sacrifice. In fact, you are patient enough. We would try to practice it and then call upon you when the need arises. And then also maybe we will make the recordings available, and then probably other students may contact you later or backstage if they have other problems.
That's
Thank
fine.
you so much for your time.
You're welcome. So before you go, I have just shared a link.
Okay.
It's actually a feedback form. I would plead with you guys to access the form and then let us know what you think about the seminar.
Right.
And then what new perspective, and I mean, you can leave your comments so that the next one will be improved. Okay. Yeah. So I've shared the link. Francis will also put it on the various pages for you so you can use to access it. Thank you very much.
All right. Thank you, Doctor.